Hello everyone, welcome back. This next video from Advanced Data Debugging course. In this one we're going to understand the most commonly used commands and how to use it, and also understand a couple of internal details of the CLR or Data framework. So we have to have a thorough understanding of how the process and threads looks like. This is very important for debugging, so I'm just gonna recap how the different threads are there in the process. Okay, so consider a process, in this case w3wp.exe, and you can see that we have w3wp.exe, and w3wp.exe basically, what I meant is, it can be any process. Okay, it can be your console application, it can be a wpref application, it can be anything. So this WWPX, it consider any process, and you have threads executing your code. These threads could be some of the functions, which is some of the DLLs which is loaded into the process by default. For example, WWP has which is the worker process for ASP.NET, which runs inside when you run any website in IIS. It has a lot of native modules like provided by Microsoft, and some ASP.NET thread stuff. These things would automatically be running inside that. So any process for that matter, even if it's a Windows application, there would be threads inside the application which runs some kind of GUI, or something which is timer thread, or something which is not written by your code. So this thread, these number of threads, like any application you take, you'll have number of threads, and you'll have native threads and managed threads. We already had looked at it. So the native threads, managed threads is again in native threads, but the CLR handles internal details of the thread, and the CLR or GC can interact with these managed threads and get information from the stack and so many other details it can do. So that thread is basically runs your C# or VB.NET code. So you can, if you categorize it, you have two kinds of threads: native threads and managed threads. So native threads, if in simpler terms, you can think of like languages which is using C++ or C. You create native threads, and your C# or VB.NET or F# creates your managed threads. Okay, so we have to understand different threads running in these things. Whenever you capture a dump of the process, it's one of the most important thing is to isolate or understand, go to the part where our application code is working. So I'm gonna go to, let me go back to windbg. So I'm gonna take 30-bit windbg, and let's take a dump. So in this one we have, um, we'll have, this is simplest console application, but if you see, you have 7 threads running. In the 7 threads, there would be managed and native threads. In managed thread will be only be there the CLR thread, only if it's CLR loaded into the process. Okay, so the just the tilde will get you just the threads. Okay, which does not, it just gives you an information of how many threads are running there. And tilde means thread, and you can say star and then k. So if you want to switch to another thread, you again use tilde only, and then this is the thread number you do, and then you switch square dash, so you go to the first thread. So if you press K, this we already seen that it'll just give you the stack. The stack can be managed as well as native. So in this case, it's a native thread. So we see a lot of entity DLL and kernel that do functions, and tilde star k will show you stack of all the threads. So that's what this command, the second command, does. Okay, so I will explain in when we go to the hang scenario, in the in this I think it would be the seventh video. We will I will explain how we can ignore all these functions, or which all functions can be ignored, so that you only look at the functions which we need. So we have 7 threads running, and I did tilde star k to go through all the threads. and display all the thread stack. And the next is bang threads. Bang threads is basically a manage commands. All the extensions commands will start with a bang. So we have bang threads. So where does this come from? This come from we previously in previous video we saw that we loaded SOAS DLL. So it basically comes from SOAS or some extensions. Okay, so we have bang threads which will show you all the managed threads running. So we have two threads and we have one more background thread, and it will give you ID, thread ID, and in what GC mode and stuff like that. We'll get to the details of this, but we have a thread object here. Okay, so this thread object is basically the CLR or managed thread object. Okay, so we have two threads, one is for finalizer and one is for our actual code, so running, so which is the zero thread. So let's switch back to zero thread, and the next is bank CLR stack. So bank CLR stack, if you do, it will give you the CLR stack. So if you do K, it'll give you functions from C++ side, and then manage, and then C++. So basically it's interleaved. As I said in the beginning of this, we have native threads and managed threads. Managed threads is also a native thread, but in between it will transition from native to managed, and then managed to native back again. That's what we see here. So but you see that CLR dot CLR here. So CLR, basically this part comes, this is the DLL and this is the function name. So the CLR is basically the DLL, uh, which is executing our C++ code which we have written in our console application, so called script. So basically what I'm trying to show here is that in one process we have threads managed native, and in one thread this is the stack, and we have, this is, each one is called a frame, and we'll have native as well as managed frames. So this is a managed frame. So this is basically the DLL, which is stack trace demo.exe. Okay, so the CLR I've explained in previous video. In Framework comes with MS Core Works or CLR.dll, depending on the which version of Framework you are. So you would actually see a lot of functions like this. So if you don't want to see it, you can actually run the CLR stack command. And the last one, to understand the thread thing, is, say what if you want to go through all the CLR stack. In that case you can do tilde star and E, and then do CLR stack, which will basically iterate through all the threads and try to dump out the CLR stack. So it goes to the first, and then dump the stack, which is the native CLR stack, and then switch to the second one. If otherwise, if without this, you'll have to manually, go and visit all the thread stack, which in this case it will not work because this is a managed. This is not a managed thread. So that's why what is this command is showing. Okay, so that's about threads. And the next thing is you have to familiarize with this called application domains. So application domain is an execution, it's an isolation when it's a mechanism inside CLR where you can create multiple app domains, or the CLR itself creates multiple app domains to isolate different parts of the application, to interact with, to not to interact with each other. So in if you're running an application code in an application domain, you can actually make it in such a way that if you create another domain, it will never affect the application domain which you first created. So we can have multiple app domains or isolated environments in one process itself, where both cannot interact, or both cannot communicate directly or corrupt. We can put it like that. So we have certain mechanism in CLR which will help isolate the code which is executing in one domain from another domain. So okay, so in this case we see that we have process, and then we have CLR is loaded, and CLR will have domains. We have application domain and application domain 2, and each application domain can have different set of assembly. Assembly is the DLLs which we create using C# or VB .NET compiler, and it will have assemblies loaded. And we can actually create custom app domains other than the ones which CLR creates. So we will see how CLR creates different app domains. So we can actually explore the app domains creator using windbg command. So in previous one we loaded SOS. So let me just check if SOS is loaded. I see that SOS would be loaded. Uh, yeah, SOS is loaded automatically by the debugger. So if I run bang help, I'll get all the help. One second, reload. We have on this guy. Yeah, okay. That command was not showing there. Okay, so I ran bang help and I got all the commands here. So in this one you see dump domain. Okay, so basically you can just do dump domain. It will dump the domains which is actually inside the process. So if you notice, um, I can only press half and then press tab. We have some kind of completion there which will automatically complete the command for you. So dump domain gives us all the domains. So if you look closely, you have system domain, you have a shared domain, and you have domain 1. Okay, so we have 3 domains. So the system domain is created by CLR to create other domains. So we have shared domain and domain 1. So CLR first creates system domain, and from using that using that domain, it creates shared domain and domain 1. Okay, so we have system domain, shared domain, default domain, which in this case is domain 1, and you can create custom domains. Custom domains can be created using the Sharp code with create domain calls. Create app domain calls, you can pass a domain name, and you can create custom domains. Okay, so coming back to WinDBG, we have system domain. So if you just pass the domain address, okay, to dump domain, it will only dump that domain and all the assemblies loaded inside that. Okay, so we only dump the domain of that and all the assemblies passed in. So this is a very simple console application, and you may not really see a lot of assemblies loaded. Let's see how it looks like in the case of a WinDBG, in case of a dump which is taken off w3wp.exe. Okay, so I'm going to load the w3wp.exe dump which we have previously taken, and I'm going to do dump domain. And if you see this, you have a lot of DLLs. You see that MS_lib here, and then you have system.service model, system.microsoft.javascript.dll, system.xml.dll. So all these things will be loaded. So in this case also you can see that there would be um, many domains, and you see domain 1 and domain 2, sorry, as shared domain, system domain, and domain 1. Okay, so that's about the domains. And one last thing about domain is that these assemblies which is loaded from the GAG, which is called domain neutral assemblies, and the same assemblies will be loaded in all the domains. If it's loaded as domain neutral, it doesn't have to be reloaded again. But custom assemblies, if you load to custom domain from your application bin directory, it has to be separately loaded for each domain. Okay, so ms_lib system.web, if it's available in the GAG, it will load that, and it will load in shared domain as well as default domain, which you would be able to see here. So in this case, this is a shared domain, and you see that system service model is here, and you would see the same thing in domain 1 as well. Okay, so you will see the same kind of DLLs loaded in system.dll as well as node services and all these DLLs, which is actually domain neutral, which is loaded as domain neutral, and which will be present in all the assemblies and doesn't have to be loaded again and again. So we went through these. We have dump domain and um, dump domain and dump domain address. Okay, and one last thing about is that we have dump domain hyphen stat, which is only available in CLR 4.0 or less. This is a dump which is loaded with 4.6, so we don't have that command available. But if you're trying this on a 4.0 application dump, you can just run stat. It will give you a statistical view like these many assemblies are present and these many domains are present. So that's about a domain. And Next is assembly. So we saw that we have assemblies here. So we have this command dump assembly, which we can use, which we can dump the assembly and get some details. And you see that it gives you a module name, modules present in the assembly. So one assembly can have multiple modules. So in this case we have an assembly, and it will tell you which is the parent domain of the assembly, and what is the assembly name, and where it's loaded actually from. And you can get this data and then to dump module, and it'll give you some more information about that, like what is the where is how what is the metadata start address, and where is the different types of metadata starts. Okay, so these are reference to metadata tables which CLR maintains, which is outside the scope of this series we are doing. You don't really have to understand it until unless you want to get to know how metadata actually works. So this is something which, for your information, we have command which can dump module, and you can actually look at the module and the metadata details. Now, next is types. So reference type, we have, you all know, you have all written code in C Sharp, or any managed .NET languages. So we have two types, basically, reference types and value types. So a reference type is like your classes, and value types is which is like integer, or your enum values and stuff like that, basically struct. So the reference types are stored in heap, and value types are stored in your stack. So we found that we have threads, and the stack is something which is allocated per thread. So value types is basically stored in the thread stack. So we will see how using windbg we can inspect looking at the type. So we have two commands, dump object and dump vc. um, so dump objects, this command, many of these commands will have short form, so we can just do bang do to get the dump object. So before that, to dump all the objects, we have this command called dump heap. If you just do, it will just dump all the objects in www.exe process dump. So we have so many type of objects here, and say I take a system.string value. Okay, so I can show this. If you look at this table, which is it's displaying dump heap, you can actually see that. Let's go to the top. So this is called empty. Empty is method table, and the count and the total, the size of each object. But what we are concerned about is something called empty, the method table. Method table is where CLR maintains everything about that CLR object. The kind of what kind of types does it contain, like what kind of fields it contains, what kind of method it contains. So for example, if you take string contains a lot of different functions, like toString, two char array, or is null or empty, string dot is null or empty. So many methods are there. So it maintains, CLR maintains all these data using the method table, and which is very important for us. So think of it like per every type we'll have a method table. So we have the same command, dump heap command, and you do empty, and it will just display all the string types, because that's the empty which we took. And then you can actually do bang dump obj and pass it and dump the string, and see that the string value system.web, and we are dumping a string value, and see we have, it will also dump the fields, like the fields of that. So basically this command will help you inspect an object in the heap. And similarly, say if this is a in system in 32, and you see that we have a field here. So if we want, we already have the value displayed here, but if it's a really long value, some custom values which it cannot be displayed by a debugger, we can actually check using dump vc. So dump vc is, you have to pass the method table and the field. Okay, and it'll give you the value again. So this is the way you dump a value type. Okay, using dump, you have to an extra detail you want is called this method table, which is whatever every whether it's value type or reference type, there will be a method table for that, and we will get the details of that. Okay, and next is you have, say, you have this dump object, and you see the method table for string is this, and the next is you have a command to inspect the method table. So for that is called dump empty. So we have dump empty and hyphen md. You have to do the switch hyphen md. Okay, if we just do this, it'll give you method table details like e class module and what is the name and stuff like that, and how many slots in the v table, or how many you can roughly equate that to methods in the in the class and stuff like that. So we'll get to the details of this. So we this is bare minimum command of dump empty, but if you pass hyphen md switch, you get all the, you know, method descriptions, or all the methods defined in that type. So this is a simple string value which we have as system.web, but if you look at it, you have so many methods of this, and these this command can shows that detail. So if you look close, you see you have all these methods: index of, ends, compare, everything is defined in the system, you know, string class. We can actually see that in the memory. So we have this entry and method description and some pre-jit. So basically pre-jit means this method is already jitted, and you know, it's already converted from IL to machine language. And to understand where or how it's got converted, we can actually get that details also with this help of debugging in dbg. All you have to do is dump md and pass the method description, which is of toString, and it says is cheated is yes, and we have a code address. So this code address is the one where the machine languages are. We will get where we'll get more understanding on this when you actually debug a scenario based on that. So we don't have to remember any of these commands, any of these concepts. You will get used to all these things when you actually do a scenario and then do a review of the scenario. Okay, so these are the main commands which we have in, you know, in windbg or these exceptions. Okay, and the next is method description, which we just went through, and next one is getting stack objects. Okay, so now I am in the 0th thread. I want to see what objects are there in the stack. I can do bang dso. This is okay, the w3wp dump. So this is not a managed thread. So let's go back to our previous dump, which is uh, the dump of stack trace. Okay, so here I'm going to do DSO. So DSO is the short form. The actual command is dump stack objects. Okay, so the same thing, and it'll dump all the objects in the stack. See that it at the stack there's a um, though I said that the value types are stored in stack. If any variable is referencing a reference type which is in the heap, this command can show that. So basically these values are present in the stack, but some of these are actually, you know, reference type, but this variable is present in the stack, so that's why it's showing. So basically dump stack object shows all the objects present in the stack, whether it's a reference type or value type. But normally value types are always stored completely in the stack, but reference type stores a pointer in the stack, and then the actual object will be in the heap. So how can we see that? We can just get this. If you stream writer, if you want to get some more details like what is the stream writer, you can do dump object or bang do for short form, and it'll we can actually dump that guy and get more understanding what values it has. So it has many fields, stream, it has a stream, and then encoding, encoder. So you can actually get all these details like that. So if you want to get more details on the encoder or the stream, system.io stream, you can actually dump that details and get that. You how you just do on that. You see that I copy that from there and then dump the value. So I got it from, so think of like you are working with a DB connection string, and you see you want to check if it's say crashing for some reason, and you want to see if my connection string is right. All you have to do is go to that thread, do use dump stack objects, and look at the string variables there and see if your connection string is there. If it's not there, you can actually go to your connection object, which you would find in the stack, just like we found an IO stream here, and we can dump the parameters of that and figure, look closely and see if its values have come correctly or not, stuff like that. So we will go through each of these or different scenarios of it. So that's about dump stack objects. And you also have something called MDSO. So the MDSO comes from SOSEX. Okay, so I'm just loading SOSEX. Sorry about that. I think I should do this guy. Okay, yeah. Okay, I loaded SOSEX, and if I do MDSO, I get the same thing. One advantage of SOSEX is that it doesn't show duplicate objects. And if you look at this one, it has actually had a bigger list because it was showing some objects were duplicates. Okay, so that was one problem with dump stack objects, but SOSEX does not show that. Another advantage is that you get clickable. So if you want to get more details of your writer, you can just click on it, and then about stream, you can click on it. Then about a particular handle, you can click on it, and then you can dig deep like that. So that's another way of looking at the dump stack objects. Both serve the same purpose. The same command is available in two different debugger extensions. Okay, actually this dump stack object is available in many debugger extensions. I think it is available also in net.ext, which we have referred in a previous video. Okay, so that's about getting the stack objects. And next, last but not least, we have something called dump class, which you would dump, you can use to inspect the types of a class. So here you have this class, and you can get these details, and then dump class you can do, and it basically you can just see what are the types or fields of this system string has, and you can just inspect that and say some methods, you want to see what is defined, how that method, how that class is defined, some class, and how the class is defined, what fields does it contain, and all. You can inspect that. You can also get details of this using a static variable, because static variables are basically stored in the type, not in the object. So even dump class can also be used to inspect static variables as well. So here you will see the values of that, the static variable, if it's actually available for different domains. Okay, so in this one it's not there, so that's why it's not showing anything. Okay, so that is about dump class, and that's all we have to get familiar with the different commands. So I will add a reference as well to this slide deck, and you can refer that in the debugging.io website. So once you go through this video, please make sure you open up the windbg, try these different commands, try the helps, try the help of each of this extension. You can do bang help, and then say dump object. If you want, you can just do dump object. It'll give you more information about that command, and just get familiar with the different commands. Thank you for watching. Please go to the next video, which is how we can debug a hang scenario. Thank you.